Chapter 3. Write a fraction represented by the shaded region. Assume that the entire figure represents a number 1. So recall that a fraction is a part of a total. So let's count how many parts do we have here out of the total. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12. Like the total is 12 pieces, right? And how many pieces are shaded? 1, 2, 3, 4, 5, 6, 7. So this is 7 out of 12. So the answer should be 7/12 is a fraction that represents all of this shaded region. Number 21, we're going to have in 21, they're asking to find the missing numerator. So they're giving you 5/8 is equivalent to what over 24. So we're trying to look for numbers that they're equivalent, they're exactly the same. So how are we going to do this? We're going to see 8 times what number give me 24. So recall that 8 times 3 is 24. So what will happen here is that 8 times 3 give you 24. So if I multiply times 3 to get to a 24, I also should multiply this 5 times 3. So it will be 5 times 3 should be 15. So my missing numerator in this part should be answer 15. That's how you find equivalent fractions. Now, problem number 22. In problem number 22, they want you to simplify, or in other words, reduce to its lowest terms. What does it mean to reduce to its lowest terms? It's kind of the opposite of what we did to finding some equivalent fractions previously. So let's do this. So 180 over 2400. And there is a small shortcut here. So if these two numbers are ending in 0, yes, if it ends in 0, you will have to cross them out. So you cancel them out here. So you're, in other words, you have to reduce 18 over 240. But how are we going to do this? There are many ways of doing it. You can review the chapter 3, or what we can do here is let's break each of them into a product of prime numbers. So 18, what is 18? 18 is 6 times 3, so you put 6 times 3 instead of the 18. And this 24 times 10 was gonna give you 240, so that should be 24 times 10. But you see that nothing can cancel out here, so you keep breaking this into product of prime numbers. So that 6 should be what? The 2 times 3 and the extra 3 that I have there. And this 24 can be 3 times 8, and this part here could be a 2 times 5. So let's cancel them out now. So this is gone because they are pretty much the same. So on top you're left with a 3, and at the bottom you're left with 8 times 5. Recall that 8 is 2 times 2 times 2, and there will mean not 3 to cancel out, because the only thing you have left on top is a 3. Therefore your final answer should be 3 over 8 times 5. So it should be 3 over 8 times 5, which in this case should be 8 times 5 is 40. So your final answer should be 3 over 40. Once again, there are many ways of doing this particular exercise. So look over chapter 3 and you will find more examples how to do. Sometimes you can break into product of prime numbers, do the prime factorization, and then see what numbers you can cancel out. So going to the next problem, we're going to have to do more simplification. So we have to reduce this now into as well into a lowest term. So in problem 23, what are they giving us in problem 23? Well, in problem 23, they're giving us 70 over 245. And once again, you have to do the same technique. Use a technique that you would prefer. So 245. Now, this 70, well, it can be 7 times 10. And this 245, well, it ends in 5, so it's probably 5 times something. If you want to find that out, you do your long division, and you find that out. 5 goes into 24. I will say 4 times, because 5 times 5 is 25, so that will be kind of too much. So it will be 5 times 4, and 4 times 5 is 20. We subtract that. 4 minus 0 is 4. 2 minus 2 is 0. So now bring the next number down. So 5 goes into 45 9 times. 9 times 5 should give you a 45. You subtract that, that gives you 0. Therefore, it means that 245 is actually 5 times 49. Well, there's nothing that we can cancel out yet. So, but this 7 is a prime number, so I cannot break it down. However, this 10 is a 2 times 5. And we can see that we have a 5 that we can cancel out later. And this 49 is in your times table, which is a 7 times 7. Now look at this part here. We can just cancel out the 7s and the 7s. And whenever you cancel out, just try to put a 1 there, just in case you're left with nothing, so you can see that there is a 1 there. Now there is a 5 and a 5 that we can cancel out, so you're left with pretty much the 2 and the 7 at the bottom. So 2 over 7. So that should be your final answer. That was it for problem 23. Now that's how we're gonna have to simplify numbers into the lowest term, fractions into the lowest terms. Now problem 24, they want you to convert an improper fraction, convert to an improper fraction. So in 24, they are giving you, this is called a mixed numeral. This is called a mixed numeral. So the characteristic of a mixed numeral is that it have a whole number and a fraction next to it. And we can convert this into an improper fraction. They want you to convert this into an improper fraction. So recall that these are equivalent. They can be the same because they want you to convert it. So they are going to be the same. They are going to be the same fraction. It's just that it's a mixed numeral, but they are both equivalent. So how are we going to do this part here? Well, the technique to do this is that we're going to have to multiply this big number times the denominator. So you have to do 6 times 7, and then you have to add the top. So 6 times 7 is 42, plus 3 should be 45. Perfect. So that should be 45. And now, see, this needs to be a fraction, so it has to be over something, over the same denominator. So in this case, it's 7. So you just multiply 6 times 7 plus 3, 45, and keep the 7. Just a small example here I could give you is if I give you 2 and 3 3/5. So you, once again, you have to multiply 5 times 2 and then add the 3. 5 times 2 is 10 plus 3 is 13. So this will be equivalent to 13 over 5. We keep the same denominator. Okay. More exercises are going to be covered in chapter 3. So that will be for converting to improper fraction. But also recall that an improper fraction can be converted into a mixed numeral. So we can do this back. Well, how are we going to achieve that? Well, to do that, we have to use our long division. In problem 25, they're asking you to convert this into a mixed numeral. So convert to a mixed numeral. And to do this, we have to do our long division. So they're giving you 42 over 8. And recall once again the characteristic or the property of an improper fraction is that the numerator, the top part, that is always greater or bigger than the denominator. So you can see that 45 is bigger than 7, so it's called an improper fraction. 13 is bigger than 5, so that's what it's called improper fraction. Whenever the top part is bigger than the denominator and the bottom part, so it's called an improper fraction. Once again, here 42 over 8 is called an improper fraction. So we can convert that into mixed numeral. So how are we going to do this? Once again, we have to do a long division. 42 over 8. So have to do 42 into 8. So the top part goes always inside. So the top part goes inside. Okay. So you can recall this word that we use sometimes called fit, first inside top, like the first in a division symbol. Probably if you will see 42 divided by 8, the first goes inside or the first goes on top, first inside top. So the top part goes inside as well. Okay, you can remember that the top part goes inside. So 8 goes into 42. How many times does that go? The closest one I can guess will be 5, because 5 times 8 is 40, and 6 times 8 will be 48. So that's too much. So it should be 5 times 8. So it goes 5 times 8 is 40. We subtract that. That will be 2 minus 0 is 2. 4 minus 4 is 0. So you're left with 5 wholes and 2 8s. So Now what am I going to do with these numbers? So I like to prefer doing the clockwise method, so I use this clockwise. I go this way, knowing that I will start with a big 5 and I'll write a 2 8s. Now, but recall that every mixed numeral must be reduced to its lowest terms. Now, this is fine, but this part has to be simplified. Is this simplified? Is this to lowest terms? Maybe these 2 8s, you can reduce it. Can you reduce that? Well, let's see. This is 2 over, and this 8 is 2 times 4. So you can clearly see that you're having the 2 cancel out and the 2 cancel out there. And that's why we put the 1 there. So you know you're left with 1 on top and the 1 times 4 on the bottom, the 4 in the bottom part. Because sometimes when we don't write this 1 here, we can tend to be say, oh, there's nothing left, there was only the 4 as the final answer. But no, there is a 1 there that is left over, so it should be 1/4. So instead of writing this part here, these 2 8s, I'm gonna have to write a 1/4. So my final answer is 5 and 1/4.